Hello guys, I hope I find you well today and ready to receive something also from us. And I hope you are enjoying our videos, and we are going to try our level best, to move on and make sure that you get good content that will help you get good results also. So if you are new to this channel, I also advise you to become part of the family by simply subscribing and also um, clicking that bell button that comes after subscribing, okay, so that whenever I send any video or upload any content on this YouTube channel, you'll be able to get it while it's still fresh. Okay, so what we want to do is try and look at how do we solve triangles. When I was at school, this topic was quite troublesome, but I just saw that it's such a short topic. I used to think that maybe it's a long topic, but now I see that it's a very, very short topic. So we want to cover it in a short while. Stay tuned and get yourselves ready to do something about them. Okay. Let us start by defining what is a triangle. So a triangle is a three-sided plane shape. Okay. It is a three-sided plane shape. Now, we need to look at how the triangles can be drawn. Okay, that's very important. To see how do we draw triangles, we understand that they must have three sides. But how we draw them leads to what you call classes or types of triangle. So we need to look at what you call types of triangle. Okay, so we said there are two types of triangles which are normally right angled triangles and non-right angled triangles. So let us look at how do we solve these types of triangles, okay, and what do they look like. We know that triangles must have also three sides, but now we have two types. So how do we know that this one is right angled and this one is non-right angled? Let me not waste time and show you here from the shapes that I have. So I'm going to take this one. You see, this one is what you call a right angle triangle, and then I have another one that's called a non-right angle triangle. So we have also this one, what we call a non-right angle triangle. What is the difference when you look at them? The difference is only on the fact that right angled triangles, you have got an angle of 90 degrees here. See, this is the difference. But if you look at a non-right angled triangle, you'd find out that all of the angles are curved. There is no 90-degree angle here. So this is the difference between a right angled triangle and a non-right angled triangle. And that's how you differentiate them. If you are given a triangle, let me just do it for argument's sake here. Let's say you are given this type of a triangle. Okay, and then it is drawn like this. Okay, according to mathematical principles, this is not a right angled triangle. Unless if this angle is marked 90. If it is not marked 90, then it's not a right angled triangle, okay? Because it might be 91 degrees, 92 degrees. So when you look at it, it looks like a right angled triangle. But the fact that this angle is not four cornered, this one. If it was with four corners like this, okay? If it was four cornered like this, we were going to say it's a right angled triangle, but because it is curved, then it means it's a non-right angled triangle. That's the only warning you need to take heed of whenever you're dealing with triangles. mind on what your triangle is like. Is it right angled or is non-right angled? It's very, very much important. Don't just jump into saying because I'm seeing it looks like. No, you are to determine your triangle as right angled or non-right angled because of this angle. Okay, fine. Let us move to the next part. Okay, so the formulae that we use to solve triangles are 4. So let me just say here I've drawn 4 diagrams so that I can help you understand the concept behind the formulae. So we have got, let's say, triangle 1 and triangle 2 are right angled triangles, and then we have triangle 3, and then we have triangle 4 are non-right angled triangles. So the first thing that you need when you are looking for the best formula to solve for triangles is to do what you call naming. That's the first thing. Okay, so you need to be able to name your triangle. How do you name your triangle? You need to name all the sides and all the angles within that triangle. So this means, let's consider triangle 1. If triangle 1 has got an extra angle or a second angle, let me say this angle is theta. Okay, so for triangle 1, you are going to see that the side that's opposite theta, let me just do it this way. Okay, so we have this side which is opposite theta, and that's this side, okay? And we have another side that's opposite the 90 degrees angle, that's this side. So how we name these sides is very simple. The side opposite 90 degrees is called the hypotenuse. And then the side that's opposite theta is called the opposite. At least we have said opposite already. So it's called the opposite, okay? And then the side that is remaining is always called adjacent. Okay, so we have 3 sides, which I'm going to summarize as follows. You know, not in all cases will they write hypotenuse. They just put HYP for hypotenuse, OPP for opposite, and then ADJ for adjacent. Okay, so these are the 3 sides of a right angled triangles corresponding to the 2 interior angles. I hope you have understood how we name a triangle that has got 2 angles inside it. But then there's a case whereby you are given a triangle like the one I have, triangle 2. Okay, when we are naming it, let us just start the usual way of, you know, naming the side that's opposite the 90 degrees angle, as we said, is called the hypotenuse. So we can make it hypotenuse, okay? And then now, which side is the opposite? Can we say this one is the opposite? No. Can we say this one is the opposite? No. Why are we saying no? Because there is no second angle. Remember, we said the opposite is the side that is opposite or that is facing the angle theta. Meaning to say the mother of the opposite is theta. Where there is no theta, you cannot have an opposite side because there is no mother, there is no son. That's right. So meaning to say here, what you need to look at, we don't have a mother here and we don't have a mother here, so there is no opposite. Okay, if there is no opposite, then there is no adjacent. Put that in mind. So how do you name a triangle like the one in 2? Okay, it's very simple. Let me just do this. What we do is, since we see that we don't have opposite, the sides that we're supposed to have opposite, like let me just put them in blue. Okay, so we have this one and this one. Okay, so these sides we are going to name them by letters of the alphabet to say that we don't know it can be the opposite or not, and then we don't know also. So we name them by the letters of the alphabet A, B. But you know, to make it uniform, in mathematics we must have one unit of measurement. We cannot have A, B, and a hypotenuse. So that means we are now bound to put a C on hypotenuse. So this is what leads to the question A, B, C, where C is the hypotenuse. You get the point. So always make sure that your C is the hypotenuse. Okay, let me not make my diagram dirty. I have just to remove this. Okay, so you should know that when you are given a right angled triangle, naming is very important. You need to know how do you name it. Okay, naming after theta means you will be having adjacent, opposite, and hypotenuse. Where there is no theta, you will be having A, B, and C. I hope that's sinking in. Let us now look at how do we name non-right angled triangles. This is very simple. A non-right angled triangle has got an angle A, an angle B, and an angle C. You see? And for angles, we put capital letters there. Okay? After that, we start then naming the sides. So naming the sides is very simple. You just go on using the same method. Okay? Alright. So for now, angle A is facing side called A. Okay? So angle A is facing side small letter A. And then we have angle B. Angle B is facing side small letter B. And in like manner, angle C is facing side with small letter C. So you'd find out that the angles are always capital letters. Okay, so angles have got A, B, and C. And then sides have got what you call A, B, and C. So this is how we name a non-right angled triangle. Okay, so what I want to do here is the way we named ABC here is the way we can name also any other non-right angled triangle. Is the same. But we have a scenario here. If you have a triangle like triangle A and triangle 3, whereby you have all of them corresponding. Okay, so for triangle 4, I don't want to name it myself, but I just want to show you that it's not in all cases that they put the angles inside. Like here, I just put them inside for your sake that you may see. But under normal circumstances, they just put them on top like A, B, and C. So that's how they name them. Okay, so what I want to do is this symbol. Let's consider triangle 4. It has got the 3 angles given, okay? And then remember, this is going to be side C, small letter, okay? And side A, small letter, and side B, small letter. Okay, that's very simple, and this is how we name our triangles. I believe the part of naming is now done and well explained. So what you need to do now is to move and look at what you call okay, because the processes are, we start from naming and then we go to what you call formula. Okay, all right, so we need to look at the 4 formulae now. because you cannot understand the four formulae before you understand how do you name. Now let me give you the formula that we use here. Okay, or let me just do this. Okay, so now I have these and I've made just a few adjustments on them. Let us consider the formula for triangle in triangle 1. So triangle 1 is what you call a trig ratio triangle. It works on the basis of what you call the trig ratio. So it works on what you call the trig ratio concept, okay? And then triangle 2, it works based on what you call the Pythagoras concept, okay? Pythagoras, okay? Okay, now we need to look at how and what does these two formulas say. Okay, so the first thing is the trig ratio says that when you have all the three sides of any shape or any triangle, which is the opposite, adjacent, and hypotenuse, you use what you call SOHCAHTOA, and then TOA. Okay, so I will try and explain what this means. Okay, meaning to say these are using the trig ratio of sine, cos, and tan. And sine, cos, and tan, these trig ratios, you find them from your calculator. Okay, so it says that when you have this angle, let me say theta, okay, the sine of the angle theta, this one, is given by, so we are saying the sine of theta is given by what? Alright, now let us put an imaginary stroke here, an imaginary stroke here, and a stroke here, meaning to say it's O for opposite over H for hypotenuse. So sine theta is equals to opposite over hypotenuse. Okay, and then we have cos of theta. Cos of theta, cos is adjacent over hypotenuse, so you write it as adjacent over hypotenuse. Now we are left with tan. Tan is opposite over adjacent, so you say equals opposite over adjacent. Okay, so this is it for SOHCAHTOA. So for a triangle that has got a non-hypotenuse, a non-opposite, and a non-adjacent, remember that you can use also, you can use the trig ratio concept, which is of SOHCAHTOA. Alright, that's fine and clear. Let us move to a triangle that doesn't have these things like opposite, hypotenuse, and so forth. Okay, let me just clear these so that maybe it will be fine. Okay, so we need to consider triangle 2. Triangle 2 has no opposite and it has no adjacent. So you cannot use SOHCAHTOA or you cannot use trig ratio. So it uses what you call the Pythagoras theorem, which says c to the power of 2 is equals to the sum of a and b, a to the power of 2 plus b to the power of 2. So this is the formula that you use when your triangle is named by ABC and it's a right angled triangle. Put it in mind that you are going to use c squared is equals to a squared plus b squared remember this key, that C is always the hypotenuse. Okay, C is always the hypotenuse. So these are the two formulae. We need to move to what we call the formula for the third one and the formula for the fourth one. So for the third triangle, if you can see here, it's a non-right angle triangle, but I just did some adjustments here. You see that we are given an angle as well as its corresponding side, an angle as well as its corresponding side. Then C is not given, and then the side also corresponding to C is not given. So what we do is, we now know that we have a set of what you call corresponding sides and angles. So we need to use what you call the sine rule when it comes to this type of a triangle. Alright, so what does the sine rule state? So we have the sine rule. Alright, now the sine rule states that the corresponding portions or the corresponding parts should make a fraction. For example, corresponding side A is corresponding to angle A, alright, but remember now it will be a sine. So you have A over sine A should be of equal ratio to the corresponding second corresponding portions of the triangle, which is B side corresponding to its sine of the angle B. So here you'd find out that we have A to A and B to B corresponding. Likewise, in our question we find we are given B to B and we are given A to A, and C is not there. So for a question whereby we have a pair, this is going to be pair 1 and this is pair 2. So as long as the pairs are there, use sine rule. Now if the pairs are not there, look at this triangle that I have. This angle is no pair. So this means it is given as an angle, but its side is not there. And then we are given here, this side is given, but we don't see an angle from where it's coming from. So okay, we say it's not given also. So we are only given angle A, and then after being given angle A, we are given also side B and side C. No other angle, so we don't have anything that's corresponding. What do we do exactly with this type? Oh, okay, but let us there is something that I want to do. Let us put A also here. Okay, so meaning to say the only things that are matching is angle A to each side, you see, but then the rest here are not matching, so we only have one pair. We only have one pair. Then the second pair is not there, because we can't say that C has got a pair because there is no angle C here, you see. And then we cannot say B has a pair because there is no angle B here. Alright, so what can we do when the pair of corresponding components is only one? We use what you call the cosine rule. So I want you to listen very carefully. We use what you call the cosine rule, or the cosine formula. And there is so many variants of the cosine formula, but I chose only one. So I want you to listen very carefully on how do we write the simplest method, or the simplest formula of the cosine rule. So this is very simple. We need to follow these steps. First, I find that the given angle, I write it's A. So I start with the given angle, or the cos of the given angle, and then I say equals. Now you see what you need to do is to do as I'm doing here. I just want to cheat it. So you put a full stop on A, okay, and then you put first arc the side that you touch, and then you put second arc the sides that you touch, making it like a crown of a queen. Okay, so meaning to say the side that you touch is C, the side that you touch is B. So the side that you touched must be added. Okay, that means you'll be having cos of A is equals to C to the power 2 plus b to the power 2. Remember, they must have squares. The side that's remaining is a, which is opposite it. The one that is faced by an arrow, you subtract it and say minus a squared. And then remember, all the 3 should be divided by 2 is a constant. Please don't leave it behind. And then you bring this c and the b to be coefficients with 2, but without squares this time around. So you have c and then b. So the law states cos of a is equal to c squared plus b squared minus a squared all over 2cb. Alright, so these are the 4 formulae that we are going to be using when we are simplifying or solving triangles. Yeah, what I'm going to do here, I don't want to record a long video. I can see that I'm already 26 minutes. So I'm going to end this video here, and then I'm going to move on next time and record one more video that has got examples on how do we solve these ones. So if you really want to enjoy, I'll just put it in the description so that you can also continue from there. For now, guys, we can call it a day. Let's meet next time. Do not forget then to be part of the family by simply subscribing. Subscribing is for free. Do not worry. We don't need much. You just subscribe so that whenever I post content, you get it while it's still fresh. Sharp, sharp.